Good morning. This is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So today we will discuss a problem called as a dummy variable modeling. So in the last couple of lectures we have discussed the entire structure of econometric modeling, that too bivariate, trivariate, multivariate, and we have also discussed various problems with respect to econometric modeling, that is multicollinearity, autocorrelation problem, heteroscedasticity problem, etc. So today we will discuss the concept which we usually call as a dummy variable, or you can say binary variable, or categorical variable. There are many names with respect to dummy variables. So it's a very interesting technique, and it is very useful, and most of the areas it has lots of applications. Let us we start with what is exactly the structure of dummy variable modeling, and then we will highlight some of the application where we can apply this dummy variable. Okay, so the starting point is that we have a econometric modeling, say like this: yi equal to summation beta I xi I equal to 1 to n plus beta 0 plus ui. Okay, so here I equal to 1, this is intercept, this is slope coefficient, and this is error terms, and this is independent variable, this is dependent variable. This is how the model is classified. Okay, the problem is here when we discuss something about there are many ways econometric modeling can be presented. Okay, first things we have discussed bivariate, trivariate, and multivariate, where the structure is that one dependent variable and there are several independent variables, starting from one independent variable, two independent variable, three independent variable, four independent variables, like this, okay? Or you can say kth independent variables. So that means keeping one dependent variable constant, we are extending one after another independent variable, then we are saying that it is bivariate, trivariate, and multivariate, like this. Okay, so whatever may be the situations, so when we have means one structure of econometric modeling is that where there is a one dependent variable and one or multiple independent variables. This is one way of highlighting the econometric modeling issue. Another way to represent the econometric modeling is that we have several number of dependent variables, and also in the same time there are several number of, you can say, independent variables. Okay, so that means that is called as a, or that in that scenario there is means that is the situation of interdependence among various variables. So in that structures there is no such exact classification of dependent and independent, but at the particular point of time we have to specify what are the dependent variable and what are the independent variables. Of course, one dependent variable, sometimes one is independent variable to somebody else, and same thing can be also independent variable to some dependent case. Okay, it's a very, that is how it is called as interdependent. That means if y is a function of, you can say, y1 function of y2, then obviously y2 may be function of y3, like this. So it is a chain type situation. So this is another structure of econometric modeling, that is called as usually simultaneous equation modeling, or you can say structural equation modeling. So we will discuss little bit later on that aspect. So what is all about the simultaneous equation modeling and structural equation modeling. So this is the second setup of econometric modeling. In the first setup, one dependent with one or many independent variable. In the second structures with many independent and many dependent variables. Okay, so that means it is interdependence among the various variables. So best technique is simultaneous equation modeling, structural equation modeling, or you can say there is advanced technique called as a factor analysis, etc., etc. Okay, the another structure of modeling is that means another structure we usually find in this econometric modeling is that called as a dummy variable modeling. So dummy variable can be can be divided into two parts, like this. Dummy variable modeling basically divided into two parts as per the dependent structure, as per the independent structure. So that is called as a dummy dependent variable modeling, dummy independent variables, dummy independent variable modeling. Okay, dummy independent variable modeling. So that means you see here in the third structures, means in the first structures, let me highlight here. In the first structures, one dependent. Okay, let me put it in other way. Okay, let me first highlight this structure, then we will go to this dummy technique. This structure is that, so first case, one dependent, other side either one independent or multiple independent. Okay, this is one structure, and second structure is that many dependent and many independent. Of course, this is, you can say, situation 1. Why I will call it situation 1? Because here one of the standard assumption is that whatever variables, let us say I will put like this way. So, it is nothing but y1, y2, y3 up to, you can say, yk. This is x1, x2 up to, say, xk. Okay. So, this is independent classification, this is dependent classification. So, this is how we can represent. So, now 1 1, then this is simply then 1 with 2, then it is called as a bivariate, 1 with 3 multivariate. So, this is how the structure is all about. So, now in this particular structures, one of the standard assumption is that all the variables are quantitative in nature. That means it can be measured, it can be expressed in terms of substantial quantity. Okay. For instance, GDP, FDI, Forex, these are all quantitative information. If I will say what is the GDP of a particular country, what is the GDP of a particular country for a particular year, then it is some quantitative figures. Okay. So, that is the way which we can discuss this, bivariate, trivariate, multivariate, and this simultaneous equation modeling or structural equation modeling. So, in addition to this particular pictures, there is another case, or we can call it a situation 2 in the case 2. So, here there is another type of classification, means assumption is that some of the variables may be qualitative in nature. This in the first case, our standard assumption is that the variables are very much quantitative in nature. So, there is no concept of qualitative, but basically variables are divided into two parts. One is quantitative and another is qualitative. Okay. So, quantitative and qualitative. Quantitative means it can be expressed some number, some percentage, some ratio, etc., etc. And qualitative means it is just like a categorical variables or binary variable, or you can say dichotomous variables like this. This is how we have to represent that situation. It is usually called as a proxy variables. Okay. So, that means there is no direct quantitative information with respect to that variable. For instance, gender is a particular variables. If I will ask what is the gender impact on something else, then obviously gender cannot be calculated in quantitative terms. So, if I will say gender, then obviously its structure is the male and female. So, that means only information if I collect in data, then obviously I will ask you what is the gender. So, the respondent will simply reply either male or female. So, I will record accordingly on, means in that particular structure. For instance, I have y something and I have x something and I have x1 something and x2 something, x2 say the variable gender. Then I will ask you, suppose this is respondent 1, okay, respondent 1, this is respondent 2, like this it will continue. So, in that structure, suppose I will ask respondent 1 what is your y cell, it is, let us say it is income levels. Okay. X1 say it is, you can say, yes, educational levels. Okay. Educational levels. Okay. Then obviously I will ask you first what is your income, then obviously he will simply say that something else, say $100 or you can say $200, or you can say $150, or you can say $250. So like that it will continue. So then I ask the respondent again, what is your educational qualification? Then obviously we have standard structure of educational qualification, let's say undergraduate, postgraduate, or you can say matriculations, or you can say PhD, etc. So accordingly you have to record here. So let's say this is guy is called as a MSc. Okay, so this is guy called as a, you can say BTech. Okay, then this is guy, you can say PhD. Okay, this is called as MS. So this is how we have to collect data. Similarly, genders. If I ask the gender, then he will simply say male or female, like this. Okay, so that means now if I will fit a regression like this, y equal to beta 0 plus beta 1 x1 plus beta 2 x2, then obviously this is original models. So we need to have estimated models, y head equal to beta 0 head plus beta 1 head x1 plus beta 2 head x2. Okay, so now to transfer one equation to equation 1 to equation 2, we need information. So information must be, till now whatever we have discussed, information must be in quantitative shape. So that accordingly we will put this formula and we will get the beta 0 head, beta 1 head and beta 2 head. Then accordingly we have to go for the testing of significance of these parameters and overall fitness of the models and other similar type of problems like multicollinearity, heteroscedasticity, autocorrelation, etc., etc. But if variables are not in quantitative way, then obviously it's very difficult to you can say calculate beta 0, beta 1, beta 2, because it is just way of mathematics only. So we have a beta 0 formula, we have beta 1 formula, we have beta 2 formula. So accordingly we need to have some information, like we need summation y square, summation x square, summation y x1, summation y x2. If something is variable in qualitative, these are all qualitative information. So now I cannot just multiply this one. So to multiply this one, then I have to transfer this qualitative information to quantitative information. So the way we will transfer the qualitative information to quantitative information is called as a, you can say, one way of representing the dummy variable modeling. So dummy variable means it is a proxy variable. It is used as a proxy variables, and where the variable cannot be expressed in terms of some quantity. Okay, so it is purely qualitative variable. So we use the first structure is we have to collect the qualitative information, then we transfer the qualitative information into some form of quantitative information, then we can go for its estimation. For instance, if I here male female items are there, so instead of male female, I denote male is 1 or female is 2, or male equal to 0, female equal to 1. Then obviously I will transfer instead of male, I will put I will just replace control F, then put to M, then transfer replace to, you can say 0, then all M will be replace to, you can say 0. Similarly female, so I will put again control F, F, then I will replace to 1. So then obviously this particular column will transfer the entire qualitative information to some form of quantitative information, where the information is more or less binary in nature. Okay, similarly education also. So there are 4 degrees here. So I will put 1, 2, 3, 4. Okay, 1 for MSc, BTech for 2 for BTech, 3 for MS, 4 for PhD. Then accordingly I will replace instead of all MSc I will put 1, instead of all BTech I will put 2, instead of MS I will put 3, instead of PhD I will put 4. So then you will transfer into quantitative information. After that estimation is as usual the standard standard process which we have discussed long back. Okay, so now the way you will transfer this qualitative variables to quantitative variable is very top class job. Okay, so the way we will design that structure is called as a dummy variable modeling. Okay, so that means, so in situation 2, situation 1 which we have discussed is more or less means in that particular case the one of the standard assumption is that variables are quantitative in nature. So here means the moment you will go for this is otherwise called as a qualitative response econometric modeling. Okay, so this dummy modeling otherwise known as qualitative response econometric modeling, or you can say qualitative response regression modeling. Okay, qualitative response econometric modeling. So, that means there is some kind of qualitative information you will see here. So, now this is dependent classification, this is independent classification. Dependent classification can be one, can be many. Okay, independent classification can be one, can be many. Okay, so we have already discussed these 4 steps. If many, then it is called as a structural equation modeling. If you know one, then it is simply bivariate econometric modeling. If it is one many, then it is called as a multivariate econometric modeling. So, this is how the structure we have already discussed. This is case 1 structure, where all these information are quantitative, but this same problem can be transferred into qualitative response econometric modeling if any one of the particular structures or few of them in that particular setup is qualitative in nature. So, means the variable cannot be said as a quantitative variables, it is a qualitative variables. Okay. So, because the way we will transfer this statistical model into estimate, means original model to estimated model. So, you need to have information, the way we will process this information, then ultimately we will get the estimated model. So, that is how the information must be quantitative in nature, because ultimately we will process it mathematically, so that we will get the estimated value. Okay. Or estimated equation. So, that is how you need all these quantitative information. So, computer will or software will not read all these qualitative information. So, you have to by hook and crook you have to transfer this qualitative information to quantitative information. Of course, there are certain variables which cannot be expressed directly in terms of quantity. That is how the researcher has to play a main role. So, he has to find out some criteria how to transfer this qualitative variable to quantitative form, because most of the problems and where the variables cannot be purely quantitative. So, there is a qualitative variable. So, in that particular context the problem is very complex, and in that context researcher's role is very tough or very high. So, he has to be means he has to perform very well to transfer this qualitative information to quantitative information. So, now in the situation 2, the situation 1 which we have discussed already, in that case there are several structures again. So, that means here we have in the situation dependent classification and independent classification. So, now let us assume that this is y is only one structure. Okay, then it is here you can say in both the side it may be quantitative information, it may be qualitative information. This may be quantitative information and qualitative information. That means you will find dependent classification is quantitative and independent classification is both quantitative and qualitative. Okay, it may be also quantitative and qualitative only. It may be quantity which we have already discussed, but quantity quality and it is also quality, then quantity quality, then quality or quantity quality. These are all called as a dummy variable modeling. So, that means the agenda is here is that whether means there must be at least one variable which should be qualitative in nature. So, that we have to we will artificially transfer into some quantitative form. So, in that structures means when there is a question of dummy variable modeling. So, there is either means there is one dummy variables, or you can say several dummy variables. If it is one dummy variable, then you must be very careful whether it is a dummy dependent or dummy independent. If there are many dummy variables, then again you have to see how many are dummy dependent, how many are dummy independent, because the structure or you can say mathematical setup is a little bit different. Of course, the theoretical representation is very much certain, but mathematical derivation is a little bit different. So, as a result, so you have to very careful about it. So, that means in the moment you will handle this type of modeling, in the first hand you have to see what are the variables are dummy variables. Okay, and the second question is that how many variables, how many dependent variables are dummy dependent and how many independent variables are dummy dependent. Okay, dummy independent. So, accordingly you have to proceed, but we start with a simple model. The simple dummy variable modeling is that, so there should be a dependent variable which is very much quantitative in nature, and there is at least one independent variable which is dummy in nature. Okay, so that means this is the basic or easiest way to represent the dummy variable modeling. So the complexity will start when there is one after another dummy independent variable introduced in the system, the way we have discussed in the case of multicollinearity. So that means the starting point is that, so like this, the simplest structure of dummy variable is that, so dummy variable modeling, simplest structure is that it's a dependent variables and function of independent variables. Okay, so now here we will assume that this is a quantitative information, independent variables. So some are quantitative and some are qualitative. Even quantitative, qualitative, it is okay also. Okay, so that means quantitative as a function of qualitative, it is okay, or quantitative as a function of quantitative and qualitative, this is also okay. But this quantitative, qualitative, this is somewhat actually a little bit also complex, but the simplest or best procedural best structure of dummy variable modeling is in that particular format. Most of the problems you will handle in this particular issue, where there is a one independent variable which is quantitative in nature, and in another side there is at least one dummy independent variable. So that means in the right side few variables must be quantitative in nature and few variables are qualitative in nature. So among the few qualitative variable, it may be one, it may be multiple. So if it is one or in the case of multiple, the structure is accordingly designed. Okay, so we will discuss in details how is that particular setup. So now first thing is what is dummy variable. So dummy variable is usually called as a binary variable, which usually used as a proxy for other variables. So that is how the definition of dummy variable. So there are various names related to dummy variables. You can say binary variable, categorical variable, response variable, dichotomous variables. So there is so many ways we have to represent the dummy variables. So in any case, the problem is more or less same. So you just know the methodology or structure, then everything will follow up accordingly. Okay. So now what is all about this dummy variable modeling? So the standard what we will discuss here. Okay, we start with this concept called as a dummy independent structure first. That too, one dummy independent, where one dummy one dependent variable only. So this is the simplest structure. The simplest structure is that y equal to alpha plus beta x, okay, plus gamma d. Okay, so that means this is the simplest structure of you can say dummy variable modeling. This is the dummy variable modeling, that is independent dummy. Then this is a dependent variable, this is independent variable, this is a dummy variable. Okay, so this particular measurement is a quantitative, this particular measurement is a quantitative, this particular measure is a qualitative. Okay, it may be 0 1, it may be 1 2 3, or it may be like this 1 1 2 3 4 5 like this. Okay, let's say this is gender is best cited example, this is a seasonal effect is another cited example, or you can say time periods, different time periods is another cited example, and this is with respect to different colors, different regions, different countries, different states. This is how it can be classified. Okay, so that means you see here, let's say I will see here what is the sales volume with respect to product shape, this pen. Okay, so now what is the sales volume of this pen? So that means we have to know what are the factors which can influence sales volume. Let's say x is the one variable. Obviously the amount of sales depends upon price of sale, or you can say advertising involved in this particular pen. So that means it is quantitative in nature. Then there is a variable called as a dummy variable. So dummy variables, that means we like to know when a particular company's sales is forecasting, your agenda is to forecast the sales of a particular company, and obviously let us assume that your company has several branches across the country. So that means you like to know which particular city is more effective and more significant than the others. So in that case, so you have to accordingly introduce a dummy variable, that is you can call as a regional effect. So now suppose there are 5 different cities where your product is going. So which particular city is more significant with respect to your sale? So in that case you have to use for dummies. Okay, so suppose sales from south, then you will put call d equal to 1. Then sales from, you can say, north, you will put d equal to 2. Then sales from, you can say, west, you will put d equal to 3. If sales from east, then you will put, you can say, d equal to 4. Like this you have to transfer the entire sales component. So accordingly, if you go by regress estimation, so these variables cannot be, say, south, north, east, west, cannot be, you can say, estimated directly. So what you have to do, you have to transfer all these information to quantity information. For instance, you just denote south means 1, north means 2, or west means 3, east means 4. So accordingly you transfer all the south, west, south, north, east, west in terms of 1, 2, 3, 4. Then you go for estimation. Obviously you will get the better result. Okay, so this is the simplest structure of dummy. So now I will put you with the general framework of dummy. So then we will come to a specific form. So the general framework of dummy is that okay, before I highlight the general framework of dummy, okay, let me first highlight here. So let y equal to summation beta I xi, okay, I equal to 1 to n plus summation gamma I di I equal to 1 to n, okay, plus beta 0 plus u. Okay, so this is the generalized format of qualitative response regression modeling, qualitative response regression modeling or econometric modeling with independent dummy, okay. So that means it is the dummy independent variable econometric modeling, okay, dummy independent variable econometric modeling. So that means here y is always remain same, okay. So now you are just adding one after another variable in the systems in the form of quantitative or in the form of qualitative. So obviously R square will be substantially high because y is remain constant, and now the moment you will introduce one after another variable, whether it is in the form of direct x or in the form of dummy, then obviously your R square will approach to very high and f will approach to very high. But in the same times, when you will introduce one after another variable like time series analysis, then obviously by introduction time series analysis with a lag introduction. So similarly here, if you enter x or corresponding x, or we can say dummy, then obviously R square by default R square will increase, f will increase. That means model overall fitness will be high or increase, because you are increasing a simple model to multivariate model. So when we will handle multivariate model, then obviously most of the cases R square will be substantially high, okay, and f will be substantially high. But the main problem is that whatever variables you are introducing, all these variables should be significant, okay, otherwise it is unnecessary to introduce any particular variable. What we have learned from multicollinearity, so let us say that there are 5 different variables. So 3 are, you can say, quantitative variables and 2 are qualitative variables. So now out of all these variables, so we have to first go through original regression introducing all these variables. But by default, if you go by all these variables without initial any testing, then obviously some variable may be significant and some variables may be non-significant. So in that case, but R square will be very high and f will be very high. In such a situation, what you have to do? So we have to check what is the highest percentage influence on means a particular variable which has highest influence on y. So that means in that case, if you follow the path of multicollinearity, then y has to be regressed through this first high impact variable. Then subsequently you will introduce second important variable. Then every time we will check it by introducing one after another. R square must be significant, R square must be very high, substantially increase, or adjusted R square will substantially increase. f will start increasing substantially, and in the same times whatever variables you are introducing, that must be significant. Okay, so yes, of course, the significance level may vary. So it may be, instead of in the first case if it is at the 1%, the second case it may be 5%, or you can say it may be 10%, but we have to go up to 10%. Then you see, after introducing one after another independent variable in the system, then two things must be taken care. First thing is, whatever variables you are introducing in the system one after another, then that variable must be significant, and this and it should not affect the significance of other variables. Okay, this is the number one important thing. And second thing is that the overall fitness of a model will be substantially high, and adjusted R square will be substantially high, f will be substantially high. By any chance, if you are introducing one after another variable, and by the way, significance level of the parameters get affected, and in the same times, f statistic is also getting affected, then it is better not to introduce that particular variable. So one after another variable will introduce, as long as R square will increase, f will increase, and all parameters, in whatever parameters involved in the particular system, current system, so it has to be it has to be significant. Okay, so now when we will put here qualitative response econometric modeling in general format, so this is how you have to represent. Okay, so now with this particular structure, so you can go for very simple structure, you can go for very complex structures. For instance, I will take just I equal to 1. Okay, I equal to 1. I in fact sample size, but here I am putting different way. So y equal to 1 means, so it is nothing but beta 0 plus beta 1 x1 plus d1 x1, okay, plus u. So this is the simplest for structure of, you can say, dummy variables. So now if we put I equal to 2, then obviously the system will be beta 0 plus beta 1 x1 plus beta 2 x2 plus d1 x1 plus d2 x2, okay, d2 x2. So this is how it can be extended substantially. So if I will put I equal to 3, then obviously the system will be beta 0 plus beta 1 x1 plus beta 2 x2 plus beta k plus d1 x1 plus d2 x2 plus d3 x3, and obviously here we will add beta 3 x3 plus u, okay, plus u. So this is how it will extend substantially. Okay, so that means this is generalized formula. So mathematically, if you put to allow 1 1, then it is the structure. If you allow 2 2, 2 means 2 independent variable, quantitative independent variable, and 2 qualitative independent variables. Similarly, I equal to 3 means you are introducing a system with 3 quantitative variable and 3 qualitative variables like d2 d1 d2 d3. Okay, similarly beta 1 x1 x2 x3. So now if you introducing one after another variables, then one thing you must, means two things you must be very careful. The variables which you included in the system, it should be significant, and by the way, by the process of a significance level, so others should not affect their significance level. If introducing of another variable, new variables, if the overall significance of the variable is increasing and significance of individual parameter is also increased, then you are in the right track. But if you are after introduction of new variables, if the other variables are drastically in the negative side and getting affected the overall fitness of the model, then in that case it is better to stop that variable. We should not introduce that variable in the system. So this is how we have to extend the structure of dummy variable econometric modeling. Okay, so now obvious question is why it happens, this particular structures, and is it essential or is it, that means we like to know what is the nature and consequence of this particular modeling. Okay, so the nature I have already explained. So the nature means obviously it is a system where few variables are quantitative and few variables are qualitative. So that is the nature. So that is how the way, but regression will not effective if a system consists of both quantitative information and qualitative information. So, of course, initially you have quantitative information and qualitative information, but when will you go for its estimation, the moment you will enter to the estimation process. So, that times you must you must have a file where all these information should be quantitative in nature. So, okay. If not, then your first job is to transfer this qualitative variable to quantitative variables. The way like this, I have given a problem which we have discussed earlier. BSc, IIP, money supply, wholesale price index, and exchange rate. So I'll put one factor, that seasonal effect. Let's say there is another factor, we introduce seasonal factor, or else this is the time series analysis. So let's say the time periods which the information which we have right now is a 1992 2009. Then I like to know what is the impact of global financial crisis, okay, or you can say what is the impact of Asian financial crisis on this particular inflation rate or India's money supply. So in that case, so you have to see what is the impact means. So you have to introduce the dummy variables, okay. So that means, so if we say Asian financial crisis in 1996, then keeping 1996 remain constant or one level, so you have to change accordingly. For instance, so up to 1996 you have to put use a 111 or 000, then other one you will put 1111. So that means it will give you the signal of the impact of Asian financial crisis. Now if that particular coefficient is significant, so that means there is such variation with respect to that dummy variable. Otherwise, if not significant, that means there is no such impact. So if it is significant, then obviously Asian financial crisis has an impact on, you can say, money supply, or you can say inflation. Otherwise, it is not. So just we are theoretically assuming. Yes, theoretical assume means there is some minor level of impact. So if there is a minor level of impact, it should not be considered at a higher level, that too at the statistical way. So you must be very careful about all these issues. So now basically when will you go for you may have any form of model. So whether it is cross sectional modeling or time series modeling or penal data modeling or you can say regression modeling. So variable, two things are very important. One is variable choice, variable classification, and another is the informations, okay, informations. So that means, so the information must be always with you, so that you can go for estimation. So now if the variables are, some variables are proxy and some variables are quantitative in nature, that times you have to do lots of things, otherwise it is very difficult to, you can say, go to a particular conclusions, or sometimes it cannot be possible to estimate until unless you transfer this qualitative information to quantitative information. So this is the fundamental issue of, you can say this dummy variable econometric modeling. So that means it does not matter that dummy variable modeling, it can be time series problem, it can be cross sectional problem, it can be penal data problem. Obviously the introduction of dummy may be with respect to cross sectional unit, with respect to time series units. For instance, the way we have highlighted, this is time series dummy. Sometimes cross sectional dummy also there, like say regional effect, state level effect, or you can say something other way, gender effect, etc. These are the things which dummy variable has to be introduced, and the estimation can be captured through dummy variable technique only. So this is how the basic starting point of this dummy variable econometric. So that means what we like to means why, what are the things we like to know are that means the variables which we are collecting usually may be quantitative, may be qualitative. If it is quantitative, then it is very good for you. So you need not put any extra effort or extra labors. But if it is some qualitative informations are there, some variables having qualitative informations are there, then that contest you have to play a fantastic role. That means you have to design the transformation, appropriate transformation, then after that you have to estimate the models. Otherwise computer will not directly read if you use the software. Even if you go by manually or you can exam point of view, it is very difficult to handle this type of problem, because if I will say what is the gender, gender is say x2 variable, and x1 is, you can say, income variable. So I cannot just multiply these two. it is very difficult, means mathematically you cannot multiply anything with qualitative information. So it should be very quantitative in nature. So that means we have to transfer the entire structure into quantitative form, so that the structure can be built properly. Okay. Okay, so now there are several structures which we have highlighted, then here I will start with that particular generalized formula, then we will discuss a part of it. Okay, so y equal to summation beta 0 plus summation beta I xi I equal to 1 to n plus summation delta di. In fact, I will call it here alpha I. Okay, let us say alpha I, then di. Okay, alpha I di, alpha I di. Okay, this is alpha I di. So that means plus u. So this is the generalized formula. So here or else okay, let me first highlight x is the a vector of explanatory variables. It is x is a vector of independent variables. Okay, then beta is unknown parameters. Okay, so then alpha is also unknown parameters. Then d is the dummy variable of ith numbers, dummy variable of ith number. Okay, so this is how the entire structure. So now if I will put in different way in a explicit format, then it will be coming like this: y equal to beta 0 plus beta 1 x1 plus beta 2 x2 continue beta k xk plus gamma alpha 1 d1 plus alpha 2 d2 plus alpha k dk, okay, plus u. Okay, this is how the general formula. So we start with a particular case. So particular case is let's say like this. Let's say y equal to beta 0 plus beta 1 x1 plus beta d1 d1 or you can say alpha 1 d1. Okay, alpha 1 d1 plus u. Okay, this is how you have to say. Let's say here d1 is the dummy variable. You remember one thing, when you will introduce dummy variable in the system, you must know the systematic approach behind this dummy variable or systematic way you are introducing the dummy variable. So that means there should be proper shape or structure. As a result, you are using the dummy variable. So without having proper structure, without proper knowledge, without proper setup, you should not introduce blindly. Okay, so you must have complete or thorough knowledge. For instance, let's say I means the dummy variable sometimes mathematically it's very difficult to convince properly. So you can convince if you highlight what is exactly y and what is exactly x and what is exactly dummy. So that means in this particular structures, so we have variables y, x1 and d1. So okay, these are the variables, and our requirement is beta 0 head, okay, beta 1 head and alpha 1 head. Okay, so these are our requirement. So we have y, x1, d1. So that means by default it is looks like a trivariate econometric modeling, which we have discussed long back. Okay, but the way we discussed long back, it is the setup where all these variables are quantitative in nature. So that means only quantitative information are available for y, x1 and x2. Okay, so now here you have y informations, it is quantitative, x information, it is quantitative, but d information which is qualitative and qualitative. Okay, so now it is against the earlier discussion. That means in the earlier discussion of trivariate, where only 3 variables are there and all these 3 variables have quantitative information. So, then you can go for its estimation, but when all these information are qualitative, then obviously it is very difficult to handle. So, you have to transfer it to a proper shape. So, let us assume that for simplicity we say this is y equal to say earnings, okay, y equal to earnings, okay. X1 represents here you can say income levels, okay. In other way we will put it, this is y equal to saving and x1 is the earnings and d1 is the genders, okay. So, let us we start with the problem is that we like to know what is the impact of earnings on saving. The function is what is the impact of earnings earnings impact on saving. So, that means if I will put y equal to function of x1 here like this. So, that means y is the saving and x1 is the earnings. So, this is how the entire structure. So, that means we have earning information, we have saving information, that is purely quantitative in nature. So, we like to know what is the impact or association between earnings and savings, okay. So, is it positive or is it negative, or if it is positive or negative, so which cause and which effect. But we have already highlighted here which cause and which effect, that means saving is the effect and earnings is the cause. That means we would like to know whether earnings is the most important factor which can influence saving, okay, saving of a particular person or particular household, or you can say particular economy. So, now saving depends upon what is the earnings or income level of a particular person, particular state or particular household, okay. So, whatever we have to represent. So, you must have saving information if it is a household wise information. So, that means you take 100 households information, household 1, household 2, household 3, then every household you ask what is the income level, total annual income, then obviously you ask what is the total saving annual, and that is annual saving, then you start regressing, okay. So, the moment you will regress, then it will give you signal whether earnings has a significant impact on saving or not, but most of the instances earning has a significant impact. So, this is all theoretical knowledge, still you have to verify through econometric analysis. So, in that case you have to build a model. So, building model is the summation y equal to beta 0 plus beta 1 x1. So, that is the information with you. So, you have to just estimate properly. So, this is one way to handle this issue. So, now I will add another variable in the system. So, what is the gender impact on saving in this particular setup. So, that means I will introduce another variable, say gender. So, what is the gender impact on saving, okay. So, that means gender will go to independent side, right side, then and we like to know what is the gender influence on saving. So, obviously if I will integrate, then the saving is a function of earnings and genders, okay, earnings and genders. So, that is how we have to represent. So, now the moment we will put earnings as a earnings and gender as a factors which can be considered as for the influence of saving, then we will highlight the model structure is like this, okay. So, now here if we will introduce, you see the dummy variable by name or by indication will give you the setup, okay. The setup in the dummy variable, the setup is very important factor. For instance, here gender is there. So, gender means by default you must have theoretical knowledge to bring the setup. So, gender means there is no problem at all. So, gender how many ways gender can be represented. So, here gender can be represented in two different ways. So, male and female. So, obviously, so in that case, so gender range will be 0 and 1, okay. Gender range will be 0 and 1. So, that means we will fit this particular models. So, where di is a proxy of 1 and 0, say, okay. 1 is for male and 0 is for female, okay. So, this is how the constant I have to add in this particular system. then I will go for its estimation, otherwise it is not possible to go for its estimation. Okay. So in fact I will highlight in other way around. Okay. So let me highlight here once again. Here y equal to let us say beta 0 plus beta 1 x1 plus d into alpha 0 plus alpha 1 x plus u. So this is another way we can represent also. So we have written here first format beta 0 plus beta 1 x1 plus you can say gamma 1 d1. Okay. So now I am putting like this way. So this is another type of models which is used as a dummy. Okay. So anyway, so now here d is recognized as a 1 and 0, and y is the earnings, y is the saving, and x1 is the earnings. Okay. And d is the genders. Okay. So now if d equal to 1, then the model will be structured as a y equal to beta 0 plus beta 1 x1 plus d. Okay. So gamma alpha 1 into 1. Okay, plus u. Okay. Otherwise, if you will put in that particular format, then it will be y equal to beta 0 plus beta 1 x1, okay, plus d equal to 1. Okay, 1 into alpha 0 plus alpha 1 x. Okay. So this is another form of models. Okay. Then you see here, if d equal to 1, then this will come like this. So now what you have to do? So you simplify. So y equal to, that means this is alpha 1 and this is simply alpha 0 plus alpha 1 x. Okay. So y equal to beta 0 plus alpha 1 plus beta 1 x1 plus u. Okay. So this is how. So e of y of 1, you can say d equal to 1 is equal to simply beta 0 plus alpha 1. Okay. Similarly, if I will put d equal to 0, then okay, similarly if I will simplify this one, then it will be y equal to beta 0 plus alpha 0, okay, plus beta 1 plus alpha 1 into x1, okay, plus u. Is it okay? This is how the structure is all about. Then I will put another structure here. So now for this, okay, I will put it here only. Okay. So now if d equal to 0, then obviously y equal to beta 0 plus beta 1 x1 plus alpha 1 into 0 plus u. So it will be equal to beta 0 plus beta 1 x1, okay, plus u. So this is simple bivariate econometric modeling. And in other way, if you put like this way, then y equal to beta 0 plus beta 1 x1 plus 0 into alpha 0 plus alpha 1 x, okay, or x1, right. This is in fact x1, right, this is x1, okay, plus u. So obviously, so y equal to simply beta 0 plus beta 1 x x1 plus u. So e upon y, where d equal to 0 is equal to simply beta 0. So that means the other y, e y upon d equal to 1 is beta 0 plus alpha 1 or yes, alpha 1. So now this is the case where d equal to 0, this is the case where d equal to 1. So that means the influence factor between male and female is the alpha 1. So that is how the structure of dummy variable that is the structure of dummy variable. So, dummy variable will give you lots of hints or indication how a variable can be considered as a proxy variable and how that proxy variable can be used to estimate that particular econometric modeling. So, that is how it is a very interesting technique. So, that means you start with a variable qualitative way, then you transfer into quantitative way, then you have to go for its estimation, then you come back to original position, then you highlight what is the particular means in this particular case gender impact on that particular, you can say, savings and earnings. So, this is how the dummy variable is you can say examined, or you can say utilized in the econometric modeling. In the next class we will discuss the detailed setup of, you can say, econometric modeling with the some examples, and also we will discuss the other part of the dummy modeling, that is, you can say, qualitative response dummy dependent econometric modeling. So, with this we will conclude this session. Have a nice day. Thank you.